Hi, my name is BIOL. It's 25 August 2025. This is my mapping demonstration Unit 2 presentation. Let's get into it. So here's our agenda. We're going to go through my data set, recombination frequency, gene linkage, and interference. So here's the data set broken up by genotype, offspring per genotype, whether it's parental or recombinant, whether it's a single crossover, double crossover, and a recombination event. So what we can do with this data, we can go ahead and try to find the order of the genes. So when we go to map the distances, we know what sequence they're in, right? So we have our double crossovers, A++ and plus BC. So what we can do is kind of set up different scenarios and see if they work with the double crossovers that we've seen. So if we set it up as given with ABC and plus, what we get is plus B plus and A plus C. Now, neither of these match our double crossovers, right? We have plus BC and A plus plus. So we'll move on and we'll try BAC. Now, in this crossover, we get A++ and B plus C. Now, this fits our double crossovers, right? We have a plus BC, like right here, and A++. So that's just kind of a quick, easy way to figure out the sequence of your genes. So now we know it's BAC. And here's our totals listed. This is the total of all offspring, and then totals of recombination events based on which genes are recombining. So these numbers will be useful when we get into recombination frequency, which will also serve as our mapping units for distance, and when we get into interference. So here's our recombination frequency. So what this is, recombination frequency is the frequency of recombinant offspring produced in a cross. So it's exactly as it sounds. And the reason that you can use this as a map distance is because the closer genes are together, the less likely a recombination is to occur. So your mapping distance and your recombination frequency relate to each other, they correlate. So I already did the calculations, but we'll walk through it, right? So 820, this is the number of B recombinations, and then 240 is the number of double crossover events. So you see here 240, and then 820 B. So this should give us the distance between B and A, right? A was our double crossover event. So we add them together, we get 1060. 1060, and divide that by the total amount of offspring, 5742, and you'll get a decimal. What you'll do is just convert that to a percentage, and then you get your recombination frequency, which is in a percentage form. So 18.5% for B to recombine with A. And we'll do the same for C. So we have 1980, you can see here. So we'll do 1980 plus 240, and we'll get 2,220 divided by the total amount of offspring. That gives us our decimal. We'll convert it to a percentage, and the recombination frequency for C is 3.87% for C to recombine with A, or for C to A. So, like I said, we can use that as our map units apart from each other, right? So I'll show you on the next slide, actually. So from B to A, 18.5 mapping units, right? Because the recombination frequency is 18.5%. Same with A to C, 38.7 mapping units. And then you can get your total, or your mapping units between B and C from that. So this kind of also relates to gene linkage. if gene linkage is likely occurring if recombination frequency is less than 50%, but is likely not occurring if your recombination frequency is closer to or equal to 50%. And we can see our recombination frequencies aren't super close to 50%. It's definitely likely for B and A, starting to get closer to 50% with A to C, but not quite there, so there's definitely gene linkage occurring. So now let's talk about interference. Interference is calculated by the difference of 1 and the coefficient of coincidence. Coefficient of coincidence is calculated by observed double crossovers over expected double crossovers. So let's figure out how you calculate that, right? So observed is already given, right? We know that we have 240 double crossovers. We added the 100 from A++ and the 140 from plus BC. So that gives us 240. So that part's super easy. We have our 240. And you'll just divide that by the total. So let's see, 240 divided by 5742. So that gives us 0.04, let's round up to 2. So there's our observed. And for expected, you're going to use your mapping units, your recombination frequency, because that can determine what double crossovers you would expect to see, right? So we have probability for beta crossover is 0.185 times C's probability of crossing over, 0.387. Okay, so we get 0.0732. So now we're ready to calculate our COC. So let's see. COC. Okay, so we get 0.58 and a bunch of 3's. So there's our coefficient of coincidence, and all interferences is 1 minus 0.583, and I can already tell it's going to be a positive number, so that'll give us 0.417. And since our interference is positive, we know that there's positive chromosomal interference. So that's how you calculate interference and apply it to your findings, as well as recombination frequency and finding the distance between genes. Thank you for your time.